In this lecture, we are going to talk about production and resource use. So we'll talk a lot about the different decision-making tools that businesses have to decide how much of a product to produce and how to best use their resources to do so. And these are the topics we're going to cover: economic competition, perfect competition and perfect markets, inputs, something called the production function, production relationships, and this is going to involve looking at a lot of graphs, but we'll take it slow and kind of try and define each one so you get a good understanding of it. And then we have the 3 stages of production, so 3 different levels of production that a business could be in, costs and revenue. And this is what people typically think of when you say the word economics. They're thinking of costs and revenue, how businesses make decisions about levels of production and the use of inputs, and how do they maximize their profits? How do they make the most amount of money? So let's start off talking about economic competition and different market types. So first of all, what is economic competition? Competition is a word that we all know, right? We compete with one another in sports, or we compete with one another in our jobs or in the business world. In economics, competition is the fact that sellers are competing with one another to sell their products to buyers. And then buyers at the same time are competing with one another to purchase limited goods and services. So that's competition in the economics. That's the economics definition of competition. And there are 2 basic types of competition. There's imperfect competition and perfect competition. So what's the difference? Well, imperfect competition means that there are only a few firms that produce a particular good or service. So because they have little or no competition from other sellers, they can decide what the price of their product should be. So we call these kinds of firms price makers. In imperfect competition, the seller is the price maker. They get to decide how much to charge for their product or their service. So this includes markets like monopolies and oligopolies, and we'll define those in just a minute. But in contrast, perfect competition means that there are many sellers of a good or service that are producing a particular good or service to serve a market. So because they have to compete with one another for buyers, sellers are considered price takers. They don't get to decide how much to charge for their product. They have to take whatever price the market offers, because you can't have one farmer selling cucumbers for $12 a pound when everyone else is selling cucumbers for $2 a pound. They all kind of have to be in the same price range to compete with one another. Now, absolutely perfect competition doesn't really exist in reality, but agricultural markets come pretty much closer than any other type of product to perfect competition. So we'll look at that in just a few slides. But first, monopoly. So what is a monopoly? We all know the board game, but a monopoly in economics is one firm is responsible for the sales of a particular good or service. So it's a market in which one firm sells all of a particular kind of product. And this usually happens when the startup cost to enter a particular market is extremely high. So a classic example of this is utility companies. Think about the cost to set up energy infrastructure like power lines and underground power and power stations and all of the maintenance that power companies have to do on their infrastructure. That is extremely expensive. So there's not going to be many people or many firms who can afford to jump into that business. So in our area, on the West Coast, PG&E is pretty much the only company that offers electricity. So they have a monopoly in the electricity market. Now, similarly, in an oligopoly, there's a handful of firms that are responsible for supplying a particular good or service. And usually with oligopolies, the startup cost to enter the market is high, but it's not as prohibitively high as it is for a monopoly. So one good example is the smartphone market. The smartphone market is an oligopoly. There's only a handful of companies. Most smartphones now are Apple, Samsung, or Google, right? There are a few others, but they don't really have very much market share. So it's mostly these three companies. They control the market. So they can decide how much they want to charge for their product because there's not a whole lot of competition. Same thing with a monopoly, especially for a monopoly. PG&E can decide how much it wants to charge for electricity because sellers won't just switch to another company. They can't. There is no other company. So there's no other company for PG&E to compete with. So they get to set the price of a good or service. They are price makers in both monopolies and oligopolies. Another example of an oligopoly is the market for streaming services. Now, it kind of seems like more and more streaming services are popping up every day, but there's a handful of major ones. So like Netflix and Hulu and Tubi, or I don't know what all the kids are using these days, but there's only a handful of them that control most of the market, so they get to decide how much they want to charge for their services. Now, in comparison with perfect competition, so those last two, monopoly and oligopoly, those are imperfect competition. With perfect competition, you have lots of sellers who are supplying the same good or services, or more or less the same good or services. So think about the market for t-shirts. There are lots of brands that produce t-shirts, and sure, there's some differences between them, but for the most part, a t-shirt is a t-shirt, and consumers will be able to say, I'm not going to buy that $50 t-shirt because there's a $20 t-shirt available. So sellers have to compete with one another for that consumer's dollar. So in perfect competition, the seller does not get to just decide what price they want to charge. They have to take whatever price they are given by the market. So some agricultural examples would be that many farms grow number 2 field corn. Number 2 field corn is the type of corn that is most corn crops in the U.S. And this is corn that's grown for food processing, making corn syrup, making corn starches. It's also used for making ethanol and making corn-based plastics and those kinds of things. So this is a big crop. And pretty much all of the number 2 field corn in the nation is the same thing. Same thing with like celery or onions or any other food staple. For the most part, no matter who you buy it from, you're getting pretty much the same product. So that's perfect competition. So let's see. Yeah, perfect competition. We have what we call price takers, right? The seller is the price taker. Because they have to compete with so many other sellers selling the same good, they can't decide what they want to charge. They have to take whatever price the market offers. So let's do a pause and reflect question really quick. What does it mean to be a price taker? And why can't farmers typically be price makers? Go ahead and pause the video now and answer this. Right, and let's remember that we do need to turn in our pause and reflect questions in our note sheets to get credit for the note sheets. So make sure that this is either at the very top of your paper where you'll put all of your pause and reflect questions, or if you've already started taking notes, it could be on a separate piece of paper that you turn in. Okay, so the perfect market. Like I said, there isn't really a perfect market in existence. And there are four conditions that define a perfect market. So even markets that come really close, like the agricultural goods markets, they come close to meeting all of these four conditions, but they don't exactly meet all of them. So the first condition is that everyone in the market is selling the same exact product. So for example, we are all selling number 2 yellow field corn. It's all of the same quality. The second condition is that anyone can start or stop selling at any time. So as long as you have the startup funds, you can enter the market. So there are no legal limits to the amount of growers that can grow number 2 yellow field corn. There's no permitting that you have to go through. The startup costs aren't totally prohibitive. There's access to loans that can help you with that. And the farmer can retire or stop selling at any time. So sellers have complete control over when they start or stop selling. The third condition is that there are many sellers, so no one can control the price of the product. We talked about being a price taker. There are many sellers, no one can control the price. The fourth condition is that everyone has access to the information they need, both to produce the product and to buy the product. So producers, like farmers, they have access to things like weather reports, USDA crop information, and market prices to help them make decisions. They have all the information that they need to do their job and produce their number 2 yellow field corn. Consumers, likewise, they can purchase the products in a public market. You don't need, a permit to buy them or anything. And there's complete transparency. They know exactly what they're purchasing. So why is there no such thing as a perfect market, even with the agricultural market, which comes very close? Well, no existing market meets all of these conditions perfectly. So not all goods are exactly identical. We do have differences in quality of goods. You could also think about the fact that we have organic goods versus conventional goods, goods that are grown locally versus grown far away. There might be a difference in the freshness or the quality of produce. And then barriers to entry exist for everyone wishing to start a business. So if we go back to this, number 2, anyone can start or stop selling at any time. That's not really how things work in the real world. There are barriers to entry for everyone who wishes to start a business. For some folks, the barriers are higher, and for other folks, they are not quite as high. Some people have more money to invest in starting a business. Other people may not have access to that money. They may not have access to loans. They may not be legally allowed to own a business. So while for the most part, anyone can enter a agricultural business, it's not necessarily true for everybody. And then finally, information for buyers and sellers is often incomplete or inaccessible for some people. So we all kind of know this as buyers. You don't necessarily know exactly what you're getting every time you purchase something. And it's the same thing for sellers. There is a lot of great information out there, and as wonderful as the National Weather Service is and the USDA and all of the economists who work to put out price futures for sellers, that information is not always accurate and it's not always complete. Okay, so that's markets and competition. Now we're going to move on to inputs. So first we have to define inputs and outputs. An input is any resource that's used in the production of a good or service. Pretty simple. Output, even more simple. It's the goods or services that a firm produces. So different firms use different types of inputs. And even in agriculture, if we're talking just about farms, different farms require different inputs depending on what they produce. So for example, a wheat farm needs a combine harvester, which is this big green piece of equipment over here. It harvests the grain and then it cleans it. But a wheat farmer doesn't necessarily need a fruit washing machine. On the other hand, a citrus farmer doesn't need a combine, but they do need a fruit washing machine. So in order to kind of simplify things, we can classify inputs into common categories. And we do this so that we can come up with a set of principles or a set of decision-making tools that can be applied to any type of business. So a wheat farmer and a corn farmer can use these principles to make decisions, even though they use different specific inputs. We put the inputs into common categories. So we're going to talk about the 4 common categories of inputs in agriculture. The first one is land. Now this includes both the land itself as well as any natural resources that come on the land. This could include forests. It could include minerals. When we talk about minerals, we're talking about things like gold or silver that are in the ground, or phosphorus, anything that could be mined or extracted. We can also use minerals to refer to oil or natural gas or coal that's in the ground that could be extracted. Land also includes groundwater for sure, and depending on who you talk to, it could include surface water. That gets a little bit tricky because surface water is technically a shared resource, and just because the water crosses your land, right? Water is always moving through a landscape. Even if it's a lake, it's moving through a landscape over time. And so therefore that surface water is really a shared resource. So there are limits as to how much folks can use on their own land. Soil is another resource that comes with the land. The next type is labor, and this includes all labor except for management labor. That's a different type of input, and we'll talk about that in a couple slides. But the labor that we're talking about is the paid labor, like people planting, people irrigating, harvesting, delivery drivers, people doing weed management, operating machinery, that kind of stuff. Next, we have capital. Now, I think I mentioned in another lecture that the term capital can be used differently in different contexts. It often refers to just money, but when we're talking about inputs, it means the manufactured goods that are used in production. So the things that farmers need to buy from other firms that produce them in order to do their own production. So we could have tractors are certainly capital inputs. So are the implements. Implements are the tools that get either pushed or pulled by the tractor through the field to do different jobs like tilling and mowing and cultivating and shaping rows and stuff like that. Fertilizers and pesticides and any other chemical input you use is a capital input. And then this one gets kind of trips people up a little bit, but buildings. Buildings are capital input. It's easy to want to think of them as a land input since they are often not mobile and they come with the land, but they're actually a capital input. So fuel is another one. Any other kind of machinery or any other kind of physical input that has to be purchased from another producer. And the last one is managerial input. This is maybe the hardest one to wrap your head around because it's not a physical thing. It's the decision making that has to happen in order to organize and execute production. So managerial input could be the thinking and the experience that a farmer has that goes behind deciding how big to grow a business, deciding when to expand that business, and how to finance expansion, how to market and sell products, or selecting a variety of a crop for certain traits like drought tolerance or resistance to pests or diseases or adaptation to a certain type of climate. Those kinds of decision-making skills and the decision-making labor are managerial inputs. So again, it's not a physical thing that you're using. It's like a brain power type of input. All right, I'd like you guys to pause and reflect, answer this question in your notes. I'd like you to list a few of the inputs for each of the 4 input categories. So we had land, labor, capital, and managerial. List 2 inputs for each of the 4 categories that you would need to produce the crop that you chose to do your California crop project on. Okay, our next topic is production. So how do businesses decide how much product to produce? So first of all, we have to understand the production function. The production function is a mathematical representation of the relationship between a level of input used and the level of output produced. So this looks a little bit different from a normal equation. You can't just take this thing, which is the production function, and plug some numbers into it just like this and get an answer. This is basically a statement that says that your output is a function of this fx symbol. This means a function of, and all that means is that it is dependent on whatever is in these parentheses here. So our output is dependent on the quantity of input 1, the quantity of input 2, the quantity of input 3, and so on and so on. So what this means is the quantity of all the inputs that we use determine what the level of output is. And there's 3 different types of production relationships that we need to look at to understand this. We have the total physical product curve, the marginal physical product curve, and the average physical product curve. So let's look at the total physical product curve first. So this is a graph that shows us one of the inputs that we use, one of the inputs. And in this case, that is labor, right? And then on the y-axis, we have our output. That's the amount of product that we are producing. So this curve shows us as we increase our labor use, what happens to our output. And this is a typical shape for the TPP, or the total physical product curve. It starts off kind of steep down here. So as we go from 0 labor use up, we're increasing our output at a pretty fast rate. But then when you get kind of up here, it's still increasing, but it's less steep. We're getting less output as we add more input. And then here it peaks and it starts decreasing, right? So it starts decreasing here at I, and that's because of diminishing marginal utility. And we'll talk about that pretty soon here. Okay, so the next type of curve that we need to talk about is the marginal physical product curve. the MPP. And this shows the change in output from the addition of one more unit of an input if you hold all other inputs constant. So we're just looking at labor. Just looking at labor. So MPP is equal to a change in output over the change in an input. So it's the increase that you get in output by adding one more unit of an input. So we can see in this graph that as we go from 0 hours of labor to 1 hour of labor, we are producing 20 more units. So 20 more units than 0. As we go from 1 unit of labor to 2 units of labor, we have a really rapid increase. And maybe my line's a little bit off, but we're going to talk about this point right here. So we'll just say that at 2 units of labor, we're producing, see the graph here says 30, but 30 is the number of extra units that one more unit of labor gives you. It's not the total amount of units. And this is what sets the MPP apart from the average physical product curve, which we'll talk about next. We have to remember that as we increase our labor on this graph, what we're talking about is the marginal increase in production, not the total increase of production. So when we have 2 hours of labor or 2 laborers, whichever this graph is showing, we have actually a total of 50 here because we have the 20 units that the first laborer produced and the 30 units that the second laborer produced. So what's important to remember about this is that every one increase in labor, what you get on the y-axis isn't a total amount, it's the additional amount for that one more unit of labor. I hope that makes sense because this can be a little bit confusing. But marginal physical product curves pretty much always have this shape. They have this steep part at the beginning, and then they stop suddenly and start trending downwards. And this is because of the law of diminishing marginal returns. So I want you guys to think back to the concept of diminishing marginal utility that we talked about a few weeks ago. In diminishing marginal utility, it basically says that at a certain point, you get less and less satisfaction out of each additional unit of something. So it's really similar for the law of diminishing marginal returns. It basically means that at a certain point of input, when you keep adding more of an input, you get a smaller and smaller return in the output. So if we think of this in terms of labor, let's say that we have workers who are working in a facility that was built for 5 people to work in. If you have 2 or 3 people working there and you add one more person, you're going to get this steep uptick in productivity, right? You're becoming more efficient because you have more of the workers. But then in our facility that's built for 5 people to work in, if you start to employ 6 people or 7 people or 8 people, they're probably going to start getting in each other's way. They may need more physical space to work. They might be like sharing equipment or something. They're going to start getting in each other's way, and production is going to actually slow down. You're not going to get as much value out of each additional laborer that you add. So that's the law of diminishing marginal returns. At some point, each additional unit of an input gives you smaller gains in output. And the MPP shows us exactly how much each additional unit of an input contributes to production. So remember that these numbers here on the y-axis, this is the number of additional units that one more piece of labor or laborer contributes. It's not the total. The total is represented by the TPP over here. So the output on this one is total, and the output on the MPP is marginal. So that's the difference between them. So TPP, how much output you get for how much input you get, that's total, remember that. And then the MPP is additional output per additional unit of input. And then the average physical product curve is the last curve we'll look at in this one. And it shows the level of output for the level of one input if you hold all other inputs constant. So we're just looking at labor on this one. So in this graph on the x-axis, we have labor, and our units could be number of laborers or it could be hours of labor. And then on the y-axis, we have the average physical product. So this is the average amount, the average number of units are produced for each unit of labor. So our APP is represented as the output. So our total output, we'll just put total here to remind us, divided by our total input. And that gives us the amount of output per unit of input. So again, comparing the three of those, total physical product is how much output for how much input in total. Marginal physical product is the additional output per unit or per additional unit of input. And APP is the average output per unit of input. So the average number of units you can produce with a certain amount of input. Okay. Now we're going to move on to the stages of production. So in the stages of production, businesses are basically looking at how much of an input they're using versus the marginal and average physical products. So here we have our marginal physical product curve. Remember, this is the one that has the steep angle at the top, and then our average physical product curve. So in stage 1 of production, you're right here, you're between 0 labor use and this point right here. So in stage 1 of production, as you add more and more of an input, you're going to get this really steep MPP curve. This means that you're getting a lot more output per every unit of input that you're putting into your product. So whether that's labor, or we could be talking about fertilizer use on this x-axis. You could have fertilizer, like if we are growing corn, if you add 0 fertilizer, you're not going to get a great crop. If you add a little bit of fertilizer, you're going to get a much better crop. And then as you continue adding more fertilizer, you'll keep getting a better crop until a certain point. So this stage, stage 1, we call this an irrational stage of production. And it's irrational because you could be adding more input once you get here on the curve. You could be adding more input and still getting more output. It's still worth it to keep putting more labor or more fertilizer towards your product. Stage 2, oh wait, I forgot to mention that stage 1 ends where your MPP and your APP intersect. It ends right here. And that is where stage 2 begins, this point. And at this point, your output is still going up as you add more and more of your input, but the rate at which it's going up is beginning to slow down. So you're not getting quite as much gains from adding the same amount of input that you did during stage 1. So we begin where the marginal physical product curve crosses the average physical product curve. And then stage 2 ends here where the marginal physical product curve goes below 0. See on this graph, 0 is right here. Once MPP goes below 0, or once it hits 0, rather, once it hits 0, it means that you are not getting more output as you continue adding more input. So it's not really worth it to function on this side in stage 3, which comes next. Businesses strive to function in stage 2. They want to be in this, what we call the rational stage, where the amount of inputs that they're putting in is giving them a decent amount of returns. Once we hit stage 3, so after the MPP crosses below the 0 on the y-axis, once you go down here, you could actually be getting less returns as you add more of an input. So if it's labor, maybe this is the point where we have 20 laborers working in a facility that's only designed for 5 people. Production is going to go way, way, way down because they can't function in that space. It's too many laborers. Similarly, if we're talking about fertilizer here as our input, at some point, as you keep adding fertilizer, you'll get to a point where nitrogen fertilizer will burn your plants. It will damage the plants so that they don't produce as well. So stage 3 is considered an irrational stage of production. Businesses do not want to be functioning in here. If they're functioning in here, that means that they're putting in too many inputs, which is expensive, and they're not getting any return on those inputs as far as their production goes. So that's the stages of production. Remember, we want to be producing in stage 2 of production. Now, costs and revenue. This is where kind of all starts to come together. But there are different types of costs that we have to talk about. So total costs are the total amount that it costs a business to produce a product. And that's composed of the fixed costs and the variable costs. So what are those? Well, fixed costs are costs that don't change depending on the level of production. So they don't really care how much you're producing. If you're producing 5 units of something or 100 units of something, the fixed costs remain the same. And these are things like land, like the cost of land. So if you're renting land, your landlord doesn't care if you're producing 20 bushels of corn or 2,000 bushels of corn. They want the same amount of money every year or every month. Same thing with property taxes. It remains the same regardless of production. Insurance, for the most part, remains the same. The depreciation of equipment and buildings. So depreciation is this word that means the loss in value that capital investments have over time. So think about this in terms of a new car. If you go to a car dealership and you drive a brand new car off the lot, the second that car comes off the lot, its value starts to decrease right? And with every year that you own the car, its value keeps going down. The amount by which it goes down is the depreciation of the car. So this happens with farm equipments. Obviously, tractors are also a vehicle, so they depreciate year to year, and so do buildings. So these costs are considered, depreciation is considered a cost because the farmer or the business owner is losing value every year, and this happens at a constant rate, more or less. Taxes are more or less fixed costs when you think about, property taxes and business taxes. They change a little bit depending on how much you make, but overall they're the same. And then repair costs. These are for the most part fixed. You need to service your equipment every year. If you're, using your tractor a lot more because you're producing a lot more, sure, you might have more repair costs, but in general, they're considered fixed costs. Now, variable costs. These are the kind of costs that change depending on how much you're producing. So labor, obviously, is going to change. If you produce more labor or you produce more of a good, you're probably going to need more labor to do that. Things like fertilizer, seeds, water use, fuel use, chemical inputs like pesticides and herbicides. Feed, if you are doing livestock, you'll need more feed as you're producing more animals. And then electricity and packaging materials too. You need more, cardboard boxes if you're producing more broccoli. So let's do a pause and reflect. We all have costs in our lives. Even if we aren't producing products, we all have fixed costs and we all have variable costs. So jot down some of the fixed costs in your life and then write down some of the variable costs. What are they? Okay, let's look at some more graphs because this is economics. This is what economists do. So this graph shows us 3 different types of costs. So on the bottom on the x-axis, we have our output. So now we're switching the graphs we were just looking at for like TPP and APP and everything. They had output on the y-axis. So now we're switching to having it on the x-axis. We're comparing our output to the cost in dollars. So, like you might imagine, total fixed costs, they remain the same across the graph. So no matter how many units of output you're producing, our fixed costs here are always $100. This line is totally horizontal. Our variable costs, on the other hand, take this kind of curvy, almost S shape. So our variable costs are here, and the total variable cost starts at 0 because to produce 0 products, we have 0 variable costs, and then it goes up. The total cost, which remember the total cost is equal to the variable costs plus the fixed costs, it mirrors the variable costs, but just 100 units up because we're adding the fixed costs in. So it's the same shape and it's parallel, it's just higher up on the graph. So that's how we graph those 3 types of costs. Okay, so that was total costs, but now we need to look at average costs because these are important for making decisions in businesses. We need to know the cost per unit, not just the total cost to produce everything that we're producing. We need to break it down to the unit level in order to make good decisions. So just like total costs, we have 3 different types of average costs. We have average fixed costs, which are obviously the total fixed cost per unit of output. And then we have our average variable costs, which are the total variable costs per unit of output. And then we have our average total cost. So the total cost per unit of output. So for every 1 unit of output, you will have an average fixed cost, an average variable cost, and an average total cost. So for these 3 costs, they generally follow certain trends. For average fixed costs, they go down as output goes up. So remember that fixed costs remain the same. So we're taking a fixed cost and we're dividing it by the number of units we're producing. So we're spreading that cost out over more units. So as the output goes up, the average fixed cost goes down. For variable costs, the average variable cost goes down as output goes up. But at some point, the average variable cost will start going up because of diminishing marginal returns. So we'll look at that in a graph in a second. Average total costs, they, just like we looked at in this graph, the average total costs follow the same shape as the average variable costs, just higher up on the graph because it includes those fixed costs. Okay, so that's average costs. And now we have to think about marginal costs. So remember, marginal is one more of something. So marginal costs are how much more does it cost to produce one more unit of output. So it's equal to the change in cost divided by the change in the output. That's the marginal cost. So if we put all these things together, remember we have output down here on the x-axis and cost up here on the y-axis. This is what it looks like. So we have our marginal costs is this line here. So our marginal costs, as we begin to produce more, early on in our production, we begin to produce more, and our marginal costs are going down. They're going down. So every unit of output that we add, the cost per unit is less. When we get to a certain point, though, it starts to come up again. So up here at H, we have a pretty high additional cost for every additional unit of output. Our average total costs, use a different color on this line. So they start out kind of high, and then as we produce more units, the average total cost comes down. Makes sense, right? Our average variable costs, they're going to do this. They come down as we produce more units, and then at some point, they're going to start going up because we have diminishing marginal returns on this, diminishing marginal utility. When you get too many laborers working in that 5-person packing shed, your costs are going to start going up because they're not as efficient at their job. And then your average fixed costs, like we said, they go down. The more output you add, the more units of output you spread the average fixed costs over, and so that one keeps going down. Okay, let's talk about money. Revenue. Revenue is basically the total amount of money that comes in from the sale of a product. So we have the price of the product times the quantity sold. Pretty simple. Just how much the customers are paying in total for a product. That's the total revenue. The marginal revenue is the change in total revenue divided by a change in output. So how much more revenue do you get for every additional unit of output? In perfect markets, because sellers are price takers and don't get to decide on their price, the marginal revenue is the same thing as the price. And this is going to come in handy in just a few minutes. But remember this, that the marginal revenue is the same thing as the price, because we're talking about one change in output. The revenue from that one change is the marginal revenue. And if we just increase our output by 1, we're increasing it by the price of 1 unit, right? Okay, so that's revenue. Now, profit is something different. Profit is the total revenue minus the total costs. So it's what you have left over once you pay off all of the costs of making that product. Now, businesses, they have a goal to maximize their profit. And this doesn't necessarily mean maximizing their revenue, because what if as your revenue goes up, your costs go up faster than your revenue? Then you're going to be losing money, right? So our aim is to maximize profit here, not necessarily maximize revenue. We want to produce the amount of a good or service that makes the most money in profit. I should specify that there. And that's not necessarily the most amount of product or the most revenue. So the rule for maximizing profit is to produce at the point where the marginal cost curve, we'll highlight that here, the marginal cost curve meets the marginal revenue, which we said already is the price. So the marginal revenue is depicted by this line right here that I'm highlighting in green. Now let's go back to thinking about agricultural producers as price takers, right? Because the agricultural market is close to perfect, producers do not get to choose how much they sell their product for. They have to take whatever the market gives them. So in this case, we'll say this looks like it's maybe like $45 for whatever product this is. $45 is the price that the market decides for the goods. And so a producer would look at this marginal revenue line in comparison to the marginal cost line, and they would want to produce right here. They would want to produce where the marginal revenue line, which is the price, meets the marginal cost curve. If you were to produce more than that, if you were to keep going this way and start producing, so let's see, our marginal revenue meets marginal cost right here between 10.8 and 11.6, we'll call this 11 units. If you were to keep going and produce 12 units, 13 units, 14 units, your marginal cost, your additional cost per unit of output is higher than the price, right? So that means that with every unit you produce, you're actually losing money. So you want to produce right in here where the marginal cost and the marginal revenue meet. Okay, so let's do the last pause and reflect question. What's the difference between revenue and profit, and which of these do businesses seek to maximize? And that is it for our lecture on production and resource use. So we talked about different types of markets and competition, perfect versus imperfect. And we know that agricultural markets are as close to perfect competition as you can get. We talked about different types of inputs. So land inputs, labor inputs, capital inputs, and managerial inputs. We looked at production functions and the different curves, the total physical product curve, the marginal physical product curve, and the average physical product curve. We looked at graphs of those, and we looked at costs and revenue versus profit, and then some of the decision-making tools that businesses would use to decide what level of production they want to produce at. Remember that in agriculture, since producers are price takers, they don't get to dictate the price of the goods that they sell. So the only tool that they have to maximize their profit with is deciding what level or what level of output to produce. So that's where they have power in the market.